finally, for today, these sorts of equations, sectors, areas of a circle, triangles, the ones that look a bit like this on the exam paper. So I'm not going to do an example, I'm just going to go through everything you need to know. I'll do examples on a different video. So the main problem people have with these sorts of problems is they don't know what to do. They just say, I'm stuck, I don't know what to do. So I've come up with a sort of algorithmic way to approach these sorts of questions, which involves the use of these equations here, which I've split up handily into the word tools because they are the tools that you need to solve these equations. So you've got 5 tools, triangle area formula there, we've got these 2 here which are about circles, sector area and arc length. Both of those have to be in radians. You've got the cosine rule, I know that's an L but it does look a bit like the word cosine, you've got to admit, and the sine rule down here. So what we're going to do is, I know you know all of these, so they're all written down anyway in case you want to copy them down, but what we're going to do when we have a problem to deal with is just going to literally go down these equations seeing which one is going to be the best. So first of all you'll think, well, do I need the area of a triangle here? Or do I need sector area? Would that be helpful? Do I need arc length? Would that be helpful? Now when you get down here, I would recommend, instead of saying do I need the cosine rule, I would first of all say, is the sine rule useful? Because you can pretty much rule out the sine rule immediately if you haven't got an opposite pair. The sine rule works when you've got an opposite pair, you've got an angle and a length, and you're interested in another pair. Maybe you've got the angle and you want the length, or you've got the length and you want the angle. But either way, you have to have an opposite pair here to sub in to this part of the equation so that you can find the thing that you want on the other side. So if you've ruled out this equation and you're not interested in triangle area or sector area or arc length, then first of all have a look, have you got an opposite pair? If so, go with the sine rule. If not, you've ruled everything else out, it must be the cosine rule. So at this point you can just write the cosine rule down and go ahead and start trying to solve. So these are your tools and what they mean and what the equations are. These 2 must be in radians, the other 3 don't have to be in radians at all. So what we're going to do is look at the steps that you can take to hopefully get an accurate solution. So number 1 I've already talked about. Just go through the tools and pick the best equation that suits your problem calmly. 2, sub in what you know from the problem that you've got. And then 3, very important, check that your rules, your radian and your sector area and your arc length are in radians. Lots of people make the mistake of having the theta in degrees and it has to be in radians. Reminder of how to change to radians. You multiply by pi and divide by 180. So if you get your angle, multiply by pi and divide by 180, it'll turn into radians. Also remember that that is a pi, 180 is a pi, radians. So for example, if you've got 60 degrees, then that is pi, 180, cut into 3. So 60 degrees is pi over 3. So that's another way of thinking about it. Then, even if you're not using these, check your calculators in the right mode. It doesn't matter whether you're in degrees or radians for the other 3 equations, but you have to tell your calculator which one you're in. So if your angle is in radians, put your calculator in radians, and if your angle is in degrees, put your calculator in degrees. So this is a really important step here. And then you simply rearrange to get what you want, being very, very careful. So the only other thing I would add to this is base step here, which is stop freaking out about it, stop panicking. Okay, just go through these and do one at a time, and you should get to the end of the problem without too much trouble. I will do some examples on a different video.